Okay, so we're kind of starting a new topic here. We're doing the area. So here it says find the area of the shaded region. So we're talking about this green shaded region over here. This function right here is just the sine of x function, and it's trapped between the x-axis, which is y equals 0, and the vertical line x equals 2. Now, we have a rule anytime we're doing area between two things. We're doing the integral of the top function minus the bottom function. So in this case, the top function is our y1, which is our sine of x function, and the bottom function is going to be the x-axis, so that would be y equals 0. Now we are doing it from x equals 0 to x equals 2, so x equals 0 is going to be our lower bound. We'll call that a. And x equals 2 is going to be our upper bound, so that's kind of like our b. So our integral is going to go from a to b, so that means we're going to go from 0 to 2. Here it shows that our top function is sine of x, and we put our minus, and then the bottom function is just y equals 0. And when you have minus 0, you don't need to put the minus 0, so you can just leave it as sine of x. Now, for most of the examples in this chapter, we're just going to plug it into our graphing calculator and get an answer. So let's do that. Okay, now we're going to open up our graphing calculator. Again, this is the free one. You can see the website is ti89-simulator.com. We're going to start by typing in our function into y1. So I'm going to push the diamond and then y equals. And if I push enter, it will allow me to type anything in. My top function is just sine of x. So I do blue and then the y, and that's the sine function. Got to type x in the right parentheses, push enter, and you can see y1 is my function sine of x. Then I'm going to go to the home screen. And from the home screen, I'm going to type in this integral. So I'm going to do blue and 7. My function is in y1, so I'm just going to do y1 of x. And I'm going to do comma x. And my integral goes from 0 to 2, so I'm going to push comma 0 and comma 2 and put that right parentheses. If I just push enter, it will give me some exact value. If I push green enter, it'll give me a decimal approximation. Now I'm going to round my final answer to okay, our integral is equal to this. I'm going to put a box around my final answer. I prefer just to truncate it, so I'm just going to cut it off right there. And I don't even care what that next number is. I don't waste time rounding up or down. I just truncate it. So I'm going to put 1.416 for my final answer. All right, that's it. Let's go take a look at the next example. Okay, on the next example, it gets a little bit tougher. We have a different function on the bottom. So we have x to the 10 on the bottom. X to the 10 is our y2. It looks something like this. It's kind of like x squared. It's just a little bit flatter on the bottom. Of course, our y1 is just a basic x to the third function. So x to the third looks something like this. It's just an approximation here. And so we want to find the area of the shaded region. And so that would be this green shaded region right here. I want to find the area between those two curves. So again, it's just going to be the top minus the bottom. Now these are pretty easy to write, so you don't have to do y1 and y2. Let's just put x to the third minus x to the 10. I think that's easier. Again, you could do it either way. You can leave it as a y1 and a y2, and then you got to go and put x to the third as your y1, and you got to put x to the 10 as your y2 in the graphing calculator. Or if it's really easy, like x to the third and x to the 10 are pretty short and pretty easy, you can just type the entire thing into the home screen of your graphing calculator, and it'll just give you the answer. Now I want you to notice that we are going from x equals 0 to x equals 1. So our lower bound is going to be 0, and our upper bound is going to be 1. And that's why you see that we're going from x equals 0 to x equals 1. Now let's go ahead and type this in our graphing calculator and get a final answer. Now for this example, because the equation was so easy, I'm just going to type it in the home screen. It was pretty short, but if you have a really long function, it's better to go to y equals and then type them in on the y equals screen. Then you can go back to your home screen and just call them y1 and y2 and that kind of stuff. Okay, but this is a really easy one, so let's just type everything on the home screen. We're going to do the integral. I'm going to close the parentheses, then come back in. I want my x to go from 0 to 1, so I'm going to say x comma 0 comma and 1. And I'm just going to back it up and put the function. So my function is going to be x to the third minus x to the 10. So let's just type that in, and that's it. We'll go ahead and push enter. It's telling me that the final answer is 7/44. So it depends how the question wants your answer. Sometimes it tells you to round it to 3 decimals or to give it in 3 decimals. The exact value is 7 divided by 44, and the estimate would be 0.159. Let's put a box around our answer. All right, there we go. That's our final answer. And let's move on to the next example. Okay, for this example, we want to find the area of the shaded region again. One of our functions is 2 times sine of x. So that would be this function right here. This is 2 times sine of x. The other function is y equals 1. So that's the horizontal line right here. So the shaded region would be this blue region in between those two functions. So this is actually looking like it's pretty easy. We're going to do the integral from a to b. We don't know a or b yet. That's going to be the only hard part. But the top function is just 2 times sine of x. And the bottom function is just y equals 1. So if we can just find the bounds, the a and the b will be done. So we are going to use our graphing calculator to help us figure out what those bounds are. So here we go. Now, sometimes you can figure out the bounds without a graphing calculator. For example, if we just set this equal to 1, we can actually figure it out. If we divide both sides by 2, we can cancel these 2's, and then we get sine of x is equal to 1/2. We know where sine is equal to 1/2. That would be at 30 degrees, or pi over 6. So our a is going to be pi over 6. And if we go the same distance from pi, we would get 5 pi 6. So that would be our b. So sometimes you can solve it without a graphing calculator, but a lot of times you cannot solve it without a graphing calculator. So let's do it with the graphing calculator and see if we get the same answer. I'm going to push F2, which I can find solve. I want to solve for x, so I'm going to push comma x. Then I'm going to go back inside and just put my equation. My equation is going to be 2 sine of x equals 1. Now, the problem is if I push enter right now, it's going to give me some rule to find all the answers because there are an infinite number of answers. So let's just find the answers one at a time. Let's find the answer that lands between 0 and 1. So we want to evaluate this when x is between 0 and 1. And if you have your own graphing calculator at home, your own TI-89 Titanium, you'll be able to just push enter because you probably have the new operating system, so it will just work. On this one, it uses the old operating system, so when I push enter, it gives me some kind of error. So I cannot just write x is between 0 and 1. I have to write x is greater than or equal to 0 and x is less than or equal to 1. Now my and is going to be in the catalog under A. So I still have my evaluate, but I need to say when x is greater than 0 and when x is less than or equal to 1. So with the old operating system, I have to evaluate it when x is greater than or equal to 0 and when x is less than or equal to 1. If I push enter, it will give me my answer of pi 6. We can also evaluate it between 0 and 3, and it'll just give us both answers. So you can see I'm getting the pi 6 and the 5 pi 6. So that's the hardest part of the problem. Now we know that it goes from pi 6 all the way to 5 pi 6. So we can fill out our integral now. We go from pi 6 to 5 pi 6. All right, let's type this in our graphing calculator and just get our final answer. So I'm going to do the integral. My function is going to be 2 times sine of x minus 1. Then I'm going to push a comma x because I want to evaluate my x from. So I'm going to push comma. And we're going from pi 6 to 5 pi 6. Don't forget that right parentheses. So we'll push enter. If we push enter, it gives us this exact value. Or I can push diamond and enter, and it will give me this decimal approximation. Let's just go with the decimal approximation. Again, I don't like rounding up or rounding down, so I'm just going to truncate it. I'll cut it off right there at the third decimal. So my final answer would be 1.369, and that's it. I don't care about this 7. If you want to round up, you can. If you round up, you would get 1.370. So if you round up, don't forget that 0. That 0 means that you rounded. All right, let's go to the next example. Okay, for this example, we're trying to find the area of the shaded region. One of the things I want you to notice is that the top function over here is y2. However, the top function over here is y1. So the top function changes. Also, we have to find these x values, a, b, and c. So we're going to have to solve where this function is equal to this function. We just did that on the last example. So we're going to do it again. And if you have a new TI-89, you can just type it in like this. And one of the things I'm going to do is I'm going to help you figure out how to store all these numbers so you don't have to keep typing them in. What you don't want to do is you don't want to have a big long decimal and then truncate it or round it and then use it for more calculations. So we want to be able to use all the decimals of accuracy possible. So let's first start by trying to find our A, our B, and our C. And it's something that we're going to do with the graphing calculator. So let's get our graphing calculator. Okay, so one of the things I'm going to do is I'm just going to type the functions in on y1. My first function is going to be 2 times sine of x, so I'm going to put that on y1. Notice that it does match up with what I wrote over here. My y1 is 2 times sine of x, and I'm going to say that my y2 is going to be this exponential function. So let's type that on y2. We are doing minus 0.7, so make sure you use the minus, not the negative. The negative is below the 3. Go ahead and push enter. And before you go to the home screen, just take a quick look at them, make sure that you wrote them down correctly. Now we'll go to the home screen, and we're just going to solve where these two functions are equal. Now remember, you may have an infinite number of solutions, so we're going to evaluate it where we want. So F2 has solve. I want to solve where y1 of x is equal to y2 of x. Don't forget the parentheses x. And we're solving for x, so I'm going to put comma x. Now right now, if I push enter, it's going to give me an infinite number of answers. Let's start by evaluating for a. So we want to find maybe the number between -3 and -2. So I'm going to evaluate it. When x is greater than -3, and I want to do and, so go to catalog and get the and. X is less than -2. Now I'm going to push enter. Now it is giving me only a few decimals of accuracy, but if I go up and then I push enter, you'll see that it gives you all the decimals of accuracy that it possibly can. Now I'm going to want to store this number in letter A. So the STO down here at the bottom, if you click on that, it will store it. And then I want to store it in A, so I need to push alpha and then the A. So that will store it in letter A. Let me go back to the front and cannot have this x equals here. Now I'm going to push green enter. And now every time I push A, it's going to be equal to that number. And it may look like there's only 6 or 7 decimals of accuracy, but if you go up and grab that number, it actually has all the decimals of accuracy possible. Let's do the same thing for letter B and letter C. Letter B is between -1 and 0. So I'm going to go up here and grab my solve, push enter. That way I don't have to retype it. But I want my x to be greater than -1. So we're going to change that. And I want my x to be less than 0. Let's go ahead and push enter. And again, I want to store this as B. So I'm going to go up. I'm going to push enter. Then I'm going to push STO for store. And then I want the B, so I need to push alpha B. I'm going to erase the x equals at the beginning. Let's push green enter. And now every time I push B, it's going to give me -0.355051. And again, you might be worried, oh, it's only about 6 decimals of accuracy. Well, let's check. If we go up, push enter, we can clearly see that it is giving us many decimals of accuracy. So we won't have much round off error because, I mean, we are using rounded numbers to make more calculations. This number is only accurate up to that last decimal. But this is still pretty good. That's a lot of decimals, so I'm okay with that. Now let's do C. I'm going to go up and get my solve, push enter. That way I don't have to retype in the whole thing. Now we're going to find our letter C, which is in between 3 and 4. So we want our x to be greater than 3, and we want our x to be less than 4. We'll push enter. There we go. That's our C value. Let's go up. We'll push enter. And then we'll store this as letter C. So I'll push STO. Letter C, I need alpha and then C. I do need to delete the x equals at the beginning. I'm going to push diamond and enter. And now every time I push C, it's going to give me this number right here. Let's check. Let's go up. Push enter. And just to make sure C has a lot of decimals of accuracy, which it does. So now I've found A, B, and C, and I've stored them. We'll come back to the calculator in just a second. Now I'm not going to write down my A, B, and C because they're stored in my calculator, but we're supposed to find the area of the shaded region. So we need the area of the purple one plus the area of the green one. The area of the purple is going to be the integral from A to B, and then it's going to be y2 minus y1 because it has to be the top function minus the bottom function. Then I'm going to put plus, and I'm going to do the area of the green one. The area of the green one, it goes from B to C. The top function is y1, and the bottom function is y2. So that's what I want to type in the graphing calculator, and I can even just type the A and the B. I don't actually have to put the numbers. If this was a free response question, you make sure that you put what the actual numbers are. And it's okay just to have them to 3 decimals of accuracy, as long as when you plug them in your graphing calculator, you have all the decimals of accuracy possible. So let's go ahead and plug these into our graphing calculator and get a final answer. So I'm going to do the integral. It's going to be y2. Don't forget the parentheses of x, and then minus, and then y1 of x. Now this integral is going to go from a to b. So we need alpha, and then a, comma, and then alpha b. And we already stored the a and b values. Now I'm going to do the second integral. So I'm going to do plus, and the integral. Now this one is y1 minus y2, so be careful. And our x goes from b to c. There we go. We'll push enter and get our final answer. Okay, there we go. That's our final answer. If I wanted more decimals of accuracy, I would just go up, push enter, and there you go. It gives you many decimals of accuracy right there. So our final answer is going to be 8.293. Put a box around our answer, and that's it. Okay, our last example is a bit of a challenge problem. It says find the area of the shaded region if y2 is some line that's tangent to this curve at x equals 0. So we don't know the equation of the line, and that's what makes this one difficult. What we do know is that it's tangent to the curve at x equals 0. So that means its derivative would be the same at x equals 0. So what we basically are going to do is we're going to do the derivative of this function and then plug in x equals 0, and you'll see that we get negative 1/2. You can pause the video if you need to take a closer look at that. But that means our slope is going to be negative 1/2 at x equals 0. So we're going to use the same slope for the line that we do for the curve. We also know that the y-intercept, just based on this point, the y-intercept is going to be root 3 over 2. Now they don't give you the root 3 over 2, but if you just plug a 0 into your function, you would get root 3 over 2. So that's going to be our y-intercept. And now we've done the hard part. We've figured out the equation of this line. So now we can find the area. We just got to figure out what is our b. We know our a is 0, so what is our b value? And if we just set these two equations equal to each other, we'll be able to figure out what our b value is. So let's do that real quick with a graphing calculator. So you can see I've already plugged in the functions into y1 and y2. So now we'll just go to the home screen. And now we want to solve where y1 is equal to y2. We'll push enter. Now I want you to notice it's only giving us the answer that we needed. It did not give us x equals 0. So if you know that there's an answer here, you may have to evaluate it from like negative 1/2 to positive 1/2 to get that value. But it gave us the value we wanted, so we're going to store that as b. Okay, here we go. We're storing it as letter b. And now we can go ahead and write our integral. We are doing the integral from 0 to b, y2 minus y1. And that will give us the area of the shaded region. So let's just type that in the graphing calculator and get our final answer. Here we'll push enter. And our final answer is 1.265. I'm just going to truncate it right there. And that's my final answer.